In this lesson, we're going to revisit inequalities. We are also going to extend our knowledge and graph inequalities in the coordinate plane in two variables. So our overall essential question is, what do inequalities look like in graphical form? But first, let's remember, what is the main difference between an inequality and an equation? Well, inequalities, hopefully you know, have a less than, greater than, less than or equal to, or greater than or equal to sign. Whereas equations just have an equal sign. So how is that going to change our graphical representations? Well, hopefully you remember that with inequalities we have shading. So with our graphical representations, we're going to have shading as well, because our solutions are not just going to fall on one line or one curve. So let's begin by revisiting these four solution sets in one variable. So the first one is an equation, just x equals 2. So that's going to be a closed circle on 2, and that's it. In our second one, I have x is greater than 4. I represent that with an open circle, and I shade the values to the right. In 3, this is a compound inequality, read as -2 is less than or equal to x, which is less than 8. So what I do here is I put a closed circle on -2, an open circle on 8, and I'm shading the region in between. So x can be any of those values within that shaded region. Number 4 is also a compound inequality. This one is an OR. X is less than or equal to 3, so that would be all the values smaller than and equal to 3, but then the values greater than 5, so open circle on 5, and I shade out. So what happens now when we graph on a coordinate plane, and how will this graph look different than the graph of an equation? So consider, if you have a parabola like y equals x squared. Well, you should know that the parent function looks like this. But what would happen if I change this to y is less than or equal to? Well, the way I'm going to show the less than or equal to values is to add some shading to my graph. I'm going to shade everything less than. The third question is, how do you know if a point or a value is a solution to an inequality? Is there more than one way to tell? So one way is going to be, does it fall in the shaded region? A second way is that we can use substitution and plug it into our equation or inequality. So we're going to do 5 and 6 here. So x is less than 3. So you're supposed to know that this is a vertical line with an undefined slope. So I put a point at 3, and I'm going to add a few more points. And because it's less than 3, this would be a dotted line. If you remember earlier in the year, we did solid or dashed lines. So we're going to use a dashed, and I need to shade the less values of x. Well, the smaller values of x are going to go to the left. The directions also tell me to name 3 possible solutions, so I'm going to say -4, 0, -8, -2. All I'm doing is choosing values in my shaded region. 2, -2, and there's an infinite amount of things I could name. Number 6, y is less than or equal to -2x plus 1. So my b value is +1. My slope is -2 over 1, so I'm going to count down to right 1, down to right 1. And up to left 1. So this will be a solid line, and I'm going to shade the less than values. Now, my tip for this is, it says y is less than or equal to. So my y-axis is vertical. So I put my pencil tip on this line, and I shade straight down. So it ends up being this whole region kind of, underneath my line. And I'm supposed to name 3 solutions. So I'm going to pick this one right here. It's in the shaded region, that's -3, 2. I'm going to pick one that falls on the line because it's solid, it would be a solution, -2, 5. And then just some other one. This would be -10, -9. But lots of solutions you can name. Number 7, hopefully you recognize, is going to be a parabola. So I'm going to find 2 points. I'm going to find my vertex. My vertex would be -b over 2a. So that would be +2 over 2 times 1, which gives me 1. So my vertex is 1. And now I plug 1 into this function. 1 squared is 1. minus 2 times 1 would be negative 1 plus 1 is 0. So my vertex is 1, 0. I'm going to find one more point to the right. I'm going to substitute in 2. 2 squared is 4. Minus 4 is 0, plus 1 is 1. I'm going to use symmetry to get another point to make my smooth curve. And where I would normally just draw a parabola, smooth curve like this, I need to recognize that y is greater than, so I need to use a dashed line. So it's easy for me to erase some of my marks here. Okay, now I'm going to add my shading. Where is y greater than? Well, greater than is, I put my pencil tip on the vertex and I'm going to go straight up. So that ends up shading this region inside my curve. So 3 possible solutions will be anything inside but not on the curve. So I'm going to choose this point here, which would be 1, 1. I've got a point at 210. I have a point at 315, and there's an infinite more. Number 8, hopefully you recognize this absolute value. The vertex, opposite same, would be 3, 2. So I go right 3 up 2. The slope of my right ray is negative 2, or negative 2 over 1, so I'm going to go down 2, right 1. And to get the left ray, I'm going to go down to left 1. I will have a dotted line, or dotted V, and y is less than, so the shaded region is underneath. And my 3 possible points, 3, 0, 4, negative 5, would be right here. 3 zeros here, and I'm going to pick this one here, and the shaded region would be 1, negative 8. Now nothing on the dotted rays would be solutions. The last 2 are polynomial functions. Okay, so I know that this one is cubic and leading coefficient's positive, so it's going to look like this. I'm going to use my graphing calculator to find the zeros. So pause the video, put this in your graphing calculator, and find your zeros. So I see the graph bounces off at 0 and cuts through at 2. So it does something like this. And now I'm going to shade. Greater than or equal to will be above this curve. So again, anything in my shaded region then is a solution. So I'm going to pick 3 possible solutions, such as 2, 6, negative 4, 7, and negative 9, negative 1 would be right here. Those are 3 possible ones. Number 10 is quartic. It's got a positive leading coefficient, so I know it's going to do something like this. I'm going to use my graphing calculator to find my zeros, so please pause the video, put this in your graphing calculator, and I can see that it is crossing between negative 1 and negative 2, between negative 1 and 0, and then it's symmetrical. So since this is more of just a sketch, I'm just going to go like this. It cuts through each. And I realize I need a dotted curve, so I'm going to easily just erase here, because I can do that with this. And now I'm going to add my shading. The less than values are below the curve, so it kind of ends up being on the outside too when we go below. So possible solutions here would be negative 6, negative 7, 2, 14, nope, 2, negative 14 is what I meant to say, and I'm going to say 0, negative 5 are 3 possible solutions.